Hey Wesley, do you think I finished 62?
I do not think you finished 62. You finished 62? Do you know?
Oh, I meant 63.
I was confused. 62 is the later.
Oh, it's just See, so good. I'm so proud. You actually grabbed it. Wait, Ellie, what did you get it? I got 6 out of 10. No, 6.
I forgot. Oh yeah, I already solved it. Maybe he did with the bucket over there. And then 63. I will I hope I can extend one.
Wait, no, just
I legally can extend it.
All right, good afternoon, guys. There is a handful of assignments that you may need to turn in. I say may because some of you turned in 60 and 61 yesterday, and I think I said that you could go ahead and turn it in today because that's when my other class is going to be doing it. So you can still get full points for 60 and 61 if you didn't already turn them in. But 62/63, that was yesterday and the day before's work. And I don't know. A few of you chose to turn that in early, but it has not been asked for until now. So make sure that you either see in your binder that you've got grades for those, or come let me have them so I can give you your points. Lucy's still feeling bad. Devon. And that is up today. Okay. Try to make sure you got those things turned in the next minute or two. I'm trying to wait patiently here. Okay, so our agenda up here is actually, again, I know the dates get off sometimes because I see y'all every day, but this was for my first period class today and my second period class on Tuesday. For you guys, this is today and Monday. So roughly today, we are going to do all of 64 and start 65, and then roughly on Monday, we'll finish 65, talk about a one-question mini quiz for Tuesday, and then hopefully get you 20-30 minutes of time to use for studying for the semester exam. But again, no mini quiz next class. I know that says that, but again, that's information for you on Monday. So what I want to start off with today, and again, this won't even take half of our class period, but number 64 is a circuit on what could the original function be. So, like I said when we came back from Thanksgiving break, some of what we'd be doing is slowly previewing next semester to make it less intimidating. Because the first unit, when we come back in January, when you've not been thinking about calculus for weeks, is the hardest part of the year. So trying to balance that out. And so for the first time, we're going to start to talk about antiderivatives. So all semester, you have been doing derivatives, power rule, product rule, quotient rule, chain rule. You memorized some, you did them in the calculator. But with antiderivatives, we need to be able to go the other direction. The nice thing about antiderivatives, in my opinion, is at least for Cal AB, there's a lot less antiderivative skills than you need in derivative skills. There's a lot of things to do with derivatives. But for AB, the only type of antiderivatives you have to do is to be able to undo power rule, which we're going to look at today, undo derivatives that we memorize anyway, which we're going to look at today. Your calculator can do some integration. We'll talk about that next semester. And instead of mentally always trying to undo chain rule and product rule and quotient rule, which would be near impossible, when we're doing it the other direction, we have a process called U substitution that takes care of all of that. So, in my opinion, I think integration can be easier just because there's less things to discuss. Okay. You're welcome to write this down on the top of your paper, but I just want to kind of give you a quick little introduction about what's the difference, like how would you undo the power rule. So when we say power rule and we're taking derivatives, this is what you're about to practice on the circuit. If you had x to the n, how would you use the power rule to that? What would the process be? Well, not what's the answer, but how'd you come up with that?
Take the n, multiply it by the n, and then
Okay, so bring the power down, and then, right, and then lower the power by 1, right? So if we're going the other direction, we're going to add 1 to the exponent. We're not taking away 1 from the exponent, we're adding 1 from the exponent. And then I'm going to say this n is this n. And then divide by the new exponent. And then that goes back to the original question. So the way you want to phrase it in your head to undo power rule is bring the power down, lower the power by 1. So if we're trying to undo power rule, we're going to raise the power by 1 and then divide by the new power. Now honestly, one of the nicest things about integration is you can almost always check your answer. So let's say we had 2x to the third. So the derivative of this, you would bring the power down and lower the power by 1. So this would be like a function and his derivative. Okay, well if I start with this and want to go to that, if I raise the power by 1, it becomes x to the 3rd. Girls, y'all need to hear this. Okay, well, it doesn't sound like you will. And then divide by the new power. So if the new power is 3 and there was a 6 out front, 6 divided by 3 gives you 2. And so simply taking the derivative of your antiderivative is supposed to go back to the original question. So if it does, you know you did it right, and if it doesn't, you know you need to tweak it a little bit and do something a little bit differently. So that's one type of integration, just undoing power rule, and honestly, in about 10 minutes from now, you're probably going to feel fairly comfortable with that part. The other thing we're going to look at today is undoing derivatives that we have memorized. So what is the derivative I don't even want to ask that. What could I take the derivative of to get sine?
Negative cosine.
Wait, I thought it's when you take the derivative of sine, you get negative. Or I'm sorry, when you take the derivative of cosine, you get negative sine. So why are you saying that?
If you're taking the derivative of negative cosine, well, that's just going to be -1 times negative. Wait, is derivative of cosine negative sine?
That's what I'm asking you.
Yeah, so if you take the derivative of negative cosine, you're going to get negative sine, or positive sine.
Yes, so you're correct. You're a step ahead of me right here. So what you're probably going to think of, well, you take the derivative of cosine to get sine, but then you wait and you say, wait, hold on, the derivative of cosine's not sine, it's negative sine. So if you want it to be positive sine, oops, just multiply this guy by a negative. So what I'm trying to point out to you is, in derivatives, when you're working with sine and cosine, taking the derivative of one gives you the opposite of the other, but not the other way. When we're doing antiderivatives, those rules change. So you have to be extra careful. And the best way to be extra careful is to check. If you think this is the antiderivative of this, you should be able to take the derivative and see that it actually gives you what you started with. Checking is super important. It's going to help you find mistakes, and it's going to help you adjust little things like these negative signs. Okay, so let's look at the first few together. Notice that on your circuit, it starts off with a derivative. This is not y equals, this is y prime equals, and we are tasked to try to figure out the original function that would have that as a derivative. So don't try to mentally juggle and try to reason through this. You're going to do too many antiderivatives to do that. You need a process. So what could I take the derivative of to get 2x? Very good. Raise the power by 1, divide by the new power. 2 divided by 2 gives you 1. And then check. The derivative of x squared is 2x. So far, so good. What could I take the derivative of to get 3?
3x.
Okay, if you think that's the answer, write it down, but then check. I know that sounds silly, but the derivative of 3x is 3. So, does this have to be our answer? Wait, how not? Why not?
You could put any constant at the end of it, and then no matter what it was, it could be 0. So they're technically infinite answers.
Very good. There could be a constant, any constant. The derivative of a constant is 0, so you're not going to see it. So it could be plus 1,000,000, it could be plus 10, it could be minus 500, it could be any constant. So the habit you need to get into, that's easy to forget, is you need to say plus c, that just represents any old constant. So when we scan through our circuit here, our question 2, this is question 1 obviously, our question 2 is going to be anything that's x squared plus 3x plus a constant. Because the derivative of any constant would be 0, and again there could be a plus 0 there. Now this plus c, I'll go ahead and say now, but I'll have to say it 50 more times next semester anyway. This plus C is one of the more forgotten things in calculus. It's like kind of like chain rule in that you get so bogged down in what's the question asking and how do I do it, and then let me undo power rule, and then what am I using it for, and then a lot of times it's pretty easy to forget the plus C. So when I go around in a few minutes and look at your work, if I don't see the plus C, I'm going to tell you that your answer's wrong, even though if the rest of it looks right. Okay, so where is our question 2?
On the second page.
Right here?
Yes.
Sorry. I have a very short-term memory, so I can't remember them. Okay, so if I raise the power by 1 and divide by the new power here, what would that give us?
X cubed.
X
Or
cubed. Okay, and then check. The derivative of x cubed is 3x squared. So far, so good. Nathan, what do you think we could take the derivative of to get 2x? Okay, raise the power by 1, divide by the new power, 2 divided by 2 is 1, and then check. The derivative of x squared is 2x. Okay, what about 3? Is this undoing power rule? Do y'all consider that undoing power rule? Like, I think you know it's probably 3x, but do you see that as power rule or not? Because there's really like an x to the 0 here. There's no x's. So you could raise the power by 1, divide by the new power. 3 divided by 3 is 1. Okay, circle your answer. You think that you're done, and then you just missed it. You didn't put the plus C. The plus C in calculus is super important. There will be FRQs where you will lose a point or maybe even 2 if you forget the plus C. And an FRQ, if it's 9 points, that's over 10% of that FRQ grade. Just remembering the plus C, it's that important to calculus. Okay, what I would like you to do is I would like you to try to do 3, 4, and 5, and then I want to discuss 5 together, and then I will give you a little bit more freedom about the speed that you work this up. Actually, I want to do one more with you after that, and then I'll give you some freedom on the speed that you do that at. Oh, just put it in there. I can put it. Thank you. Now, again, I'm going to try to wait to make sure everyone's had time to get to question 5. So, I know some of you are probably already there or maybe even past there, but go ahead and just keep going with what you feel comfortable with. trying to go off of what I remember from first period. Is this question 5?
Yeah.
Did y'all get there already?
Yeah.
Does anybody want longer to get to question 5? Okay, so again, when you start doing antiderivatives of sine and cosine, you need to be extra careful. The derivative of cosine is negative sine, the derivative of sine is positive cosine. Now we're going the other direction, and so it's easy to get those rules switched up. So my advice is to just write down what you think, and if you're wrong, like I am wrong, it's okay, because you're going to spend 5 seconds checking. The derivative of -2 times sine of something would be -2 cosine of something. The derivative of a constant is 0. This is not what I started with, so I know something's wrong. It would be right if I took away the, so you take away the negative, you take away the, there you go, there you go. Then it works out, and you don't have to just hope that you did it correct. You can check by doing the derivative. Now, I'm going to show you one question where this is going to be extra important that you do the check. But the other reason that I'm going to insist that you guys do the checks next semester is because just like this semester we focused almost entirely on derivatives, next semester we spend almost until AP review almost entirely on antiderivatives. And you sometimes start to forget certain derivative rules if you don't make yourself think of those and stay up to date with those. Okay, so for example, I would like to look at, there's one on here that's a little bit tougher. This one. I don't know what question this is, but if you please look at this one for a second. This is, for right now, until you learn U substitution, I'm going to convince you how important the check is. This is pretty scary looking. The derivative is 2x e to the x squared plus 2x, and I'm supposed to figure out what did they take the derivative of to come up with that. So it's kind of hard to start, except right here, if I want e to something from a derivative, what does that tell me about the function?
So that term's in there because e to the x is just itself. So so if that's there, that means that something in the original was also e to the x.
Right, or e to the something, yeah. So e to the something gives you the e to the something. You see how you have to have this to have it in its derivative? Okay, now this is just undoing power rule, so that's a lot easier. This would have to be, what would that have to be? X squared. Okay, and then you say, I don't know how I'm supposed to come up with that 2x. Now again, at some point we'll do a process called U substitution, and in the process, if you don't want to do this in your head, you don't have to. But honestly, if you're just trying to undo one step of chain rule, U substitution is like 3 or 4 steps, and you're not going to want to do it when you don't want to. So what you should do is write down what you know has to be there, like this, and then start to check. If I take the derivative of what I think the answer is, the derivative of e to something is e to something. The derivative of x squared is 2x. And what did I not do in my derivative?
Chain.
Exactly. If I do chain rule, I'm going to multiply by
X squared.
2x. The derivative of x squared. So that's where the 2x is coming from. The 2x is coming from the chain rule. Trying to foresee what you need to multiply by to undo the chain rule is very hard. Sometimes just write down what you know needs to be there, check it, and then you can tweak it a little bit. But that's where some of those things are going to kind of show up that you don't know why they're there. So I think that's the hardest one on there. So go back to the question that you were on, please, and then I'll give you a few minutes head start, and then I'll come around and see how it's going and which ones you might need help with. Again, I don't think that this assignment should take you all of this class because these are pretty quick. So try to do a few questions on the next handout too, so that you don't get bogged down next week on Monday, please, if possible. Oh, one other plug I wanted to quickly make. Part of the reason why I like you guys to see this semester, not only so that it's not 100% new in January when you have to also start doing 10 things with it, but it also just kind of shows you before the semester exam, before you really dig in and start studying for the semester exam, if there's some derivatives that you don't know, you can start to see how that's going to hurt you second semester too, just because we're mostly moving on from derivatives. You don't know the derivative of e to something is e to something, it's going to continue to be a problem. If you don't know the derivative of natural log of x is 1 over x, you're not going to be able to undo it next semester. So I think that makes an extra case for making sure you have those derivatives memorized for the semester test, but also to make next semester go smooth as possible.
What's the derivative of magnitude? Well, it's just n. What's the derivative with respect to x of n? So if you're doing with n, that's the difference. The derivative with respect to x is n. There'll be what's the derivative of EC? No, the derivative of EC.
I didn't. I just didn't answer.
The derivative of EX is equal.
Oh my goodness. Yeah, okay.
I also.
I'm so sorry. What worksheet was that?
This was 60.
Okay, okay. Thank you. Or 12 over. Wait, you're not
Over 1 plus EC. What even?
Wait,
Yep.
I got 5.
So that is undoing a derivative we memorized. You just don't, you must not have memorized it yet because you don't recognize it. It is. It's one of the two. And what?
So it's still negative.
It looks like tangent of negative 1, but it's not. Instead of negative 1 over inverse tangent.
No, but
It's not really negative when it's not, so you shouldn't say that. It just looks like it's inverse tangent. There's also inverse sine. Yeah, 2 of the derivatives we just recently learned. The derivative of inverse tangent and the derivative of inverse sine are both on this worksheet. So if you get to a question and you say, I don't know how to undo this power rule, and it doesn't look like anything I've memorized, it could be one of those 2, and this is not as familiar yet. Y'all done with this? Okay, great. Wait, let me see if you get one of these.
Well, here's the last one.
Oh.
Y equals 6
Y'all forgot it twice.
What? But there's 16, okay? So that's not even the majority.
So 1 out of 8, that's 12%.
Yeah, that's not that bad. That's so
You guys okay with all that?
yeah. Wait. This one. We already.
Y'all done?
So good, Johnny, help. But I know it's listed. Oh, because this one goes.
You should never be trying to find your closer.
I didn't realize.
B, A.
This one,
That's our answer.
if you rewrite this as negative x plus 1 to the negative 2, if you pull that up,
Wait, but then-
then you
but
can
then
just undo power.
that's not
Right? Power by 1 divided by 1 power is done. Well, plus 2 is done.
I'm so.
Yeah. I didn't do 9 Oh, I think I have a different number.
You didn't realize the numbers.
That instead of that. I think I got confused.
I'll give you half your points back.
My 8 is similar, obviously. It's got the pen inside of it.
But yeah, the other two are actually right.
I guess I probably got it wrong.
It's right here.
I'm confused on this one. I'm guessing it connects to this, just
Oh.
goes on the answer, but I don't know.
That, okay, so that to me doesn't look anything like undoing power rule. So it must be one you have memorized, or supposed to have. Obviously not two right now.
Yeah.
1 over 1 plus x squared is the derivative of,
Would it be like a natural? I don't know.
see, now, natural log is actually a good thought, because you could do the natural log of this, but the problem is, if you do that, chain rule is gonna add a 2x that you don't have.
Yeah, you
So
said
if there was a 2x in the numerator, then you would be correct.
Yeah, that's one. That's one.
That is one of the two that we learned this week. Derivative of the inverse trig functions. Remember I told you there was 2 that you actually had to know?
So it's going It's it crosses over once here.
Inverse tangent.
2.
That one's inverse tangent. You need to recognize this one's inverse sine. Because, I mean, that's pretty much the whole thing, is just recognizing that and then plus the. So. You're done circuit.
No, not yet. I'm trying to find the paper that has the other groups.
Okay, which one are you struggling with? This? That's undoing power rule.
Oh, is it really?
But you need to move this up. You can move this x plus 1 squared up and call it x plus 1 to the negative 2. Then you can just undo power rule. You can raise power by 1 and divide by the new power.
Oh, that makes sense.
So you had to rewrite it a little bit first.
Okay.
What are you doing? Continue your wisdom. Wait, let me figure it out first. I know, that's too serious. Wait, hold on, slow down, let me.
Which one's 12? Which one's 12?
Is that one?
Wait, that's the wrong page. That's what I thought.
It's 7. Wait, what's your time? Okay. Yeah. 11 is just. So you put it 11.
Oh, I started my own
Yeah. Did that on the second one. Wait.
No, that makes sense. I tried to do that before, but that was the one where you had to do that. So I ended up not with it.
It's like 7.
Okay, I'm happy to come by and help. If you're stuck on one of the circuit questions, it's probably something I could help you with pretty fast. None of those take a ton of work, but you just have to look and think at it the right way.
Yeah, I know what it is. I just want to say
Oh, you're right.
Yeah.
Can you rewrite it? Well, if you say it's a fraction, it's 0, then it's a fraction is 0. Which is when y is 0, so that's an intersection. Okay. horizontal asymptote is describing the far ends of the graph. That's actually, it's really big or really small. So 99% of the time, here's my horizontal asymptote rule.
Okay,
And you
vertical
compare the
asymptote.
degree of the numerator to the degree of the denominator.
It's the only number we have.
You know what I'm talking about? But you can't compare these degrees in this question. So, I have to give you a time experience. So you could graph all of this, and then you could look at the y values that are broken on both sides. Well, you actually could do it without a calculator.
Because you can do,
Because if you think about the far right and left of the graph, it's talking about really big like that.
And it's gonna go to zero.
then you just have
The
the
denominator's going back.
plus.
So you can feel like the denominator's going to.
That makes more sense. I was trying to just take the derivative of this for some reason, I don't know what. Yeah, you're right.
I should start doing my notes like this. Can you even read that?
Plus 7x equals 11.
See? It's good enough then. Think about how much we can fit on the page.
11 or 11? Oh my god, I'm so smart.
In the basket, thanks. Okay, we still got about 10 minutes, so y'all need to keep at it, please.
Why does it say 0 out of 10?
Just because I was messing with me.
Oh, okay.
It's 10 out of 10.
Okay.
But before I cut off the class recording, I want to give you a couple reminders here. One is, again, what we're talking about on this circuit is a preview of next semester. This won't be on your final exam. Don't stress about it. None of that. You don't need to go home and feel like you have to remember it or recall it or anything like that. It's just a preview for next semester. But the 65 we'll spend class Monday on. It would be great if you have a couple done, otherwise it might be hard to do. And then I'll talk about this on Monday for Tuesday. So there's no mini quiz on Monday. There'll be a 1-question mini quiz on Tuesday. But again, I just wanted to make sure that we were clear there. So